Let's continue with the lab, and in this lab I'm going to show you how we can configure passive interfaces inside the RIP process, and also we are going to make some changes on the versions between two routers. We put one interface on one router on version 1 and another interface on another router on version 2, RIP version 2, and then we see if the two routers can be able to stay connected on the RIP process. Okay, let's go directly and see what we have to do in this lab. So we still have the same lab scenario, which again, you can see it over my head, the picture. And then we see the point number 1 is to set the bridge interface on router 1 as a passive interface. What does it mean, passive interface? Let me just get you here again and show you the explanation. You can see here, we have already enabled RIP over here. So we have RIP here, and we have RIP here, and we have RIP here, okay? That means the interfaces which were advertised are the connected interfaces on each of the router. Now the question is, why do we need for router 1 to send update from this interface to his inside network? Because this is a network, okay? And you may have someone having a PC who can emulate the router in his PC, and then he can grab all the routing updates that is coming from router 1. So there is no router connected from after router 1 on this network, okay? So why do you need to keep the updates going out from this interface? In this way, what we can do is to set the interface, which is here, and in our case it's bridge 1, we can set it to passive interface, and in this case what will happen that this interface will receive updates, but it will not send updates. But again, it will stay advertised for the network. That means that router 3 still know about this network, router 2 also, okay? So this is what passive interface is. Here I am now on router 1 on the Winbox. What I need to do to set the bridge 1 interface as passive interface is to go to routing, and from routing I go to RIP, okay? And from here, what we have done in the previous lab is to configure, you can see here, the advertised network to go inside the RIP process. What I need to do now, I have to go to interfaces here, I click plus, okay? And here I have to select, I want the bridge 1 interface to be a passive interface. Alright? And then I say apply and okay. So what I've done now, I just indicated to router 1 that this interface, bridge 1, is going to be the passive interface. Okay, this is the step what we need to do. This step is done. Issue ping from router 3 to 1.1.1.1. Does it still work? It should still work, because we said that the interface will stay advertised, but will not send, the router will not send update from that interface. Okay. We go to, now we are on 3.3.3.3. I go from here and I say ping 1.1.1.1, and as you can see, we still have ping. There is no problem. And if you want, we can also go inside the routing table of RIP inside here, and what we can see, the 1.1.1.1 is still there, and if we look here to the timeout, it is updating. Okay. So you remember that every 30 seconds it receives an update about this. You can see here it received an update from router 2 about this network 1.1.1.1. Okay. Let's go now and see the other steps to do. So this step is also good. Keep the ping open. So we have to keep the ping from router 3 to 1.1.1.1 open. Let me check if we have it still open here. Okay, it's still open, and it's needed because we need to do some other steps now, and that needs that the ping to stay open. Check what RIP version is used on R1, R2, and R3. Okay, let me go directly to router 1, but actually it doesn't show me here what are the RIP versions that is used on the 3 routers. But we can conclude it, because if we look inside the route here, we can see that router 1, for example, is receiving 3.3.3.0/24, again /24, and that means that the router 3 is sending the subnet mask with the routing update. The only version on RIP which sends the subnet mask with the routing update is the RIP version 2. Okay, so on all the routers, the RIP that is used is the RIP version 2. Remember that RIP version 1 is classful. That means it doesn't send the subnet mask, and it assumes the default subnet mask is the one used. Okay, so this question here, check what RIP version is used on our router 1, 2, and 3. So it is version 2. Now, what we need to do, we have to play a little bit between version 1 and version 2. And we have to change the RIP version on Ethernet 1 interface on router 1 to version 2. So we have to set it manually to be version 2. Okay. I do that. I have to go from here. And then from here, it's on side router 1. I go to Ethernet 1. And from Ethernet 1, I say for any sending I want it, or for receiving, I want it to be on version 2. For any traffic of RIP received to version 2, and the sending is to be to version 2. Okay, so now we have set it manually. We need it on the send and the receive to be version 2. All right, and then this is done. Step number 5. What we need to do now is to go to the interface, change the RIP version of Ethernet 1 interface, and router actually should be here router 2 and not router 1. Okay, and router 2 to be version 1. All right, we have already changed if we go here to the picture, we have put already on router 1 E1, we have put it as version 2, and now what we need to do to put this on version 1, and then in this case we can check if those two routers will stay connected inside the RIP process or not. Okay, so that's the idea. All right, so let me go now and to router 2 inside interface E1 and put it version 1. Now we go to router 2 and then routing RIP, and then from here interface I will go to Ethernet 1 and I put it on version 1. And then okay. Just before we go through the other points, let me just show you here that you can, if you want, to select all interfaces to be on which version you want. Okay, you can put it version 1 and 2. That means that if the router which is connected to this router, if it's using version 1, it can work with it, or if it's using 2, it can work with it. Okay, you can set inside each of the interfaces what you need to use as versions, but also many more configurations that we are going to see in the upcoming lectures, like the authentication and so forth. But now let's only look for the version 1 and version 2. All right, I will not enable this one. Now on this router we have version 1 enabled. On the other router, router 1, we have version 2 enabled. And let's see what the question here is. R3 still able to ping 1.1.1.1. Let me go to R3, and at this moment it's still, but it should not be able to ping it after the timeout is finished. Okay, if I go now to router 2, let me go to router 2. Okay, now we are on router 2 inside route. All right, this network, which is 1.1.1.0, the network connected to router 1, you can see here the router 1 is not sending update to router 2 about this network anymore. It's not because it is a passive interface. We said this doesn't make any sense. It's because the versions between the two router 1 and router 2, for the interfaces which are connected to each other, are different at this moment. So they can't understand each other. Remember, version 1 sent the broadcast as an update, while version 2 understands multicast. So you can see here the timeout is really moving, and there is no update. It's now 55. It was 2 minutes, and it's still rolling and rolling. And in a moment, we will see that router 2 will say, okay, this network, I can't reach it anymore, and the metric will be 16. Okay? So let's wait a little bit here. Let me just make it a little bit smaller, and then I open router 3. You can see now it was making ping reply, and now it is no router host. And you can see over here it set the metric to 16 on router 2. That means that it cannot reach anymore this network 1.1.1.1. And later, now you can see in a moment after the timeout here is finished also, router 2 will now is saying it's invalid, I cannot reach it. Okay, but it keeps it in its routing table. But after the timeout here is finished, you can see that he will remove totally this entry from his routing table. Okay, because he tried first, he put the time to reach this network, it didn't reach it. Then he put a timeout now, with a metric of 16, that it's unreachable, but he left it inside his routing table. But in a moment when he see that there is no any update coming anymore from this entry or from this route, then in this case he will remove it totally from his routing table. So if we wait a little bit here, and we shall see that when the timeout is finished, then in this case he will remove totally this network. Okay, and if we look now to router 1, this is router 1, and you can see that also he has put to the networks 3.3.3.3 and 192.168.23.0, which you can see it on the picture over my head here. Okay, he puts them also with a metric of 16 because he cannot reach them. The connectivity between him and router 2, the interface of Ethernet 1, the RIP is not working anymore. So he put it also 16 and waiting. You can see now, let's keep an eye now because the timeout is almost finished now. 8 seconds. And when the 8 seconds are finished, he will remove those networks. He said, I can't reach them. I don't need them in my routing table anymore. Okay, here we go. You see, the router removed them from his routing table. Same here also. You see, on router 2, he removed 1.1.1.0 from his routing table. And this is done. And is router 3 still able to ping? No, after the timeout is finished. All right. So now what we need to do is I have to reset the interface E1, the RIP version on E1 on router 2 to B2. Okay. This is router 2. I will go from here and I put it version 2 to be the same as the interface on router 1. Version 2 and version 2. And now in a moment we shall see that when the routers are sending updates to each other, here we go. You can see directly now he found 1.1.1.1. And also router 1, if we look in this is router 3. If we go to router 1 now, and you can see also he's able to see 3.3.3.0. So this is really a nice lab to show you the difference between version 1 and version 2 on RIP, and also why we need and where we need to set the passive interface. Again, to use passive interface on RIP is on an interface which should not send updates to the network which is connected to it, or to the router, which if there is any router connected to it. And let's say an example, if you have RIP environment and you have one interface which is connected to your router, to the router of your ISP, so you don't really need to keep that interface having a RIP enabled. You just make it passive. Okay, then the router of the ISP doesn't receive an update, which is not necessarily for them actually. Okay, so this is what I wanted to show you in this lab. I hope you enjoyed it, and I see you in the upcoming lecture.